Okay, we are in week 3. Grades will be updated by tomorrow. Apologize for being behind this last week. But the employee development day went well. I had a lot to do there on Tuesday. So tonight we're going to be going over network operating system in the OSI model. You have due, and did I change the due dates in here? Did we talk about that? Yeah, because with my Wednesday night class, we did that last week. I meant to ask you guys about it. Since we meet on Thursday, would it be helpful to have the due dates the following Thursday? Done. Okay, so I will do that. All right. So week 3 quiz, review questions, and then tonight's lab is actually easy for you, which is a Warriors of the Net video, which is a pretty cool video actually. It's only 13 minutes long, but it goes over network data packets and how they travel across the network. Week 4, jumping ahead to next week, we are going to be doing the lab-wise, we'll be doing the ping fax lab on week 4. We'll be doing pinging on week 4. Week 5 is your Cat5 cable. So 2 weeks from tonight is the long lab. Next week won't be so long. Week after, I believe I told you this already, that on that night when you come in, we will begin with the lab, which will be the Cat5 cabling lab. And you'll be doing a crossover cable and a straight cable, both, okay? On the back of the room there, if you see the white and red cables, you'll be doing both of those on that night. And if you do have any tools, meaning crimpers or stripper tools for cabling, you can bring those. If you don't have, don't worry about it. We've got plenty, but if you want to bring your own, you can. We do share. So that's week 5. Week 6, just jumping ahead a few weeks here, just to let you know as far as lab-wise what we'll be doing. This week we'll actually be going over network LAN lab. You'll be creating your first LAN environment, setting up a local area network with 2 or more PCs hooked together. You'll learn that on week 6. So let's get into this week's discussion on OSI model. And I will change the due dates from a week till a week from tonight. We'll do it. It'll be that way from now on. Instead of Sunday, it'll be the following Thursday. We'll do that. Oh, it's not going to take forever there. Okay. In Network Plus certification, one of the questions or a portion of the questions for the test is on the OSI model. That's what we're actually be going over tonight. And OSI is actually a standard. It's not really technical as much as procedures and more fluid, kind of a structure for networks, you could say, okay? To put different aspects of a network in different categories is what the OSI is for. So we'll look at the purpose of that, why it's used. We'll look at, in the OSI model, how 2 network nodes communicate and some of the data packet frames before we go to break, what data packets are and how they travel across the network. And then after you take a break and come back, the video talks about clicking on a link on a web page and how that data goes from that web page to the web server and then back. And this video goes over that and how data packets flow over a network. Sometimes oceanic network, sometimes wireless, sometimes wired. So standards with everything in America, you can guess, networks also have a standard company, bless you, a standard organization that sets red tape for that organization. Everybody has them, okay? We have it in education, healthcare, and also in networking. It's not all bad. In fact, some of you might want to go into this realm of networking, which is setting up rules, regulations, guidelines, procedures, and such. You might like that, okay? So standards is a documented agreement among technical folks and business and governmental facility to stipulate design and performance of a service. For instance, design and performance of Wi-Fi and the different nodes of Wi-Fi, the G, the N, the A, the upcoming new Wi-Fi that's coming out, the WiMAX. And so all these guidelines and procedures are put in paper form, they're tested, they're tried. A lot of times the military is the one that's a test bed for a lot of these, not as much the public sector. And standards are also essential in the networking world, a wide variety of hardware and software, as you can imagine. So there needs to be some de facto standard that all of them use, okay? So if you develop a Wi-Fi device, that Wi-Fi device should work with this de facto standard. And everybody should develop in that using those standards. So it's not a bad thing. Standards also define minimum acceptable performance, not ideal performance. That's one purpose of a standard. Many organizations oversee these organizations that set up these guidelines. One of them being IEEE, which does have a student branch here in Illinois. If you go to IEEE.org, you can sign up as a student while you're here at Rock Valley and be a part of the IEEE student consortium. You do get membership and privileges, conferences, magazines, free resources. They have competitions throughout the year. So a lot of cool stuff you can get involved with in the IEEE.org. ANSI is the other one that sets wireless standards as well. And then network professionals' responsibility. This is be familiar with groups setting network standards. Understand critical aspects of standards required by their own networks. And so you'll have people from different organizations, different backgrounds, different from education to government to healthcare, a part of these groups setting up the rules to, in essence, rally support for their unique area, but at the same time make sure it's a middle of the road where everybody can benefit. The ANSI is the first one, which is American National Standard Institute, has 1,000+ representatives all over from industry to governmental. These guys determine standards for electronic industry and other fields. They do request voluntarily compliance and standards. Obtaining ANSI approval requires rigorous testing. They come on site, they test your product or products, go through testing to say it's been ANSI approved, kind of like FDA approved type of thing. You put their stamp of approval on their product prior to release. ANSI standards documents are available online for good night-side reading, which nobody reads. Then the EIA, and TIA, the Electronic Industry Alliance, is a trade organization mostly comprised of the U.S. Manufacturing firms. These guys set standards for members. They help write the ANSI standards, and they lobby in Springfield for legislation to help their organizations and companies to get the criteria, components, electronics that they need passed, to laws passed to help them get the infrastructure they need for their business to grow. An example I'm thinking recently in the last 5 years, 10 years of probably the wind farms really lobbied hard before breaking out in full force the last 10 years. Had a lobby for that. The technology was proven, the benefits was proven, but they had a lobby in Springfield for about 3 to 4 years before it actually became fruition to get legislation aboard. TIA, Telecommunication Industry Association, formed in '88. They are a subgroup. The EIA subgroup merged was what's called a former United States Telecommunications Supplier Association. Say that fast 10 times. Focus of this group is standards for information technology, wireless, satellite, fiber optic, and telephone. When you see the Cat5 cabling lab, when we do that, on the actual wires themselves, they will have the TIA, EIA, whatever series that it is, on the actual wire itself as a stamp of approval for that component, medium. So anything that has to do with medium, network medium, what I mean by that is fiber, Cat5, wireless, even Bluetooth to some aspect, has to do with these guys, the EIA and TIA. The IEEE, Institute of Electrical and Electronics Engineers. International group, the goal is promote education and development in electronic engineering and computer science fields. So if you're in either one of those, if you're going into networking, programming, electronics, these are good groups to be a part of. They host symposiums, conferences, and chapter meetings throughout the U.S. I know they have Schaumburg, Chicago, 5 or 6 times a year. One big conference in the summer and also in the spring. They maintain a standards board. The IEEE technical papers and standards are very highly respected. Then ISO, the International Organization for Standardization. These are headquartered in Geneva, Switzerland. And if you do own a manufacturing company of any type that manufactures and patents things, you're more likely going to be involved with these folks and be having them approve your standards and your patents. It's a collection of standard organization representing 56 countries, and the goal is to establish international technological standards for global exchange of information and barrier-free trade. And they have widespread authority. And the reason that people in the US need to be involved with the ISO for patents is if the ISO organization puts their stamp of approval on your patent and you sell it to another country, that other country, by having the ISO stamp of approval, since it's an international standard, looks more favorably upon it, and they'll probably be less likely to try to do any shady type of deals with your patents. Because in some countries, U.S. patents have no bearing. None whatsoever. They have bearing here, but not cross border. And so this organization helps kind of bridge that gap of that divide. The ISO organization. ITU, International Telecommunication Union. These specialize in the United Nations, regulate international communication, provides developing countries, third world countries with technical expertise, equipment, founded in 1865. They joined the United Nations in 1947, and they're members from 191 countries. The focus of this group is global telecommunications and worldwide internet services. So I have a cousin that's on his 6th tour in Iraq, and one of his jobs is helping this group set up Wi-Fi in villages, remote areas that don't have internet. And so they're doing satellite Wi-Fi hotspots for not only the troops, but the folks that live there to get education, online education, and things of that nature, at no cost to the villages and places that are installed. It's really cool stuff. They got like, cafe, Wi-Fi spots in the middle of nowhere, basically. So these little tents with computers and laptops, and so pretty rewarding. And so this group helps with that venture. It's not perfect, but it's an umbrella, and they do have a lot of support with all 191 countries, and so a lot of technology. ISOC, Internet Society, these guys were founded in 1992. Professional Membership Society establishes technical internet standards. The current concerns for this group is a rapid internet growth, keeping internet accessible, information security, stable internet addressing services. This is where you'll find out more about this semester, but IP6 came out, IP version 6 came from this group. We're now mostly on still IP version 4. IP version 6 gives us more IP numbers, more ranges of IP numbers. And also they're open standards, meaning they're opening it up to other organizations to help them build these standards that have yet to exist. And they look generally 20, 30, 40, 50 years down the road. They oversee groups with specific missions. They oversee the Internet Architecture Board, which is a technical advisory that oversees the Internet's design and management. And then the Internet Engineering Task Force. These guys set Internet system communication standards, particularly protocol operation and interaction. Anyone can submit a proposal to this group and elaborate, review, testing, and approval process is with this Internet Engineering Task Force. So anything has to do with communication standards goes to this subgroup. IANA and ICANN. The first is the word IP. You've heard of that maybe. Internet Protocol. It's address that identifies a computer on a network. So if you sit in front of a computer, it has a certain IP address. It's much like your social security number identifies you, or a VIN card. A VIN number recognizes a vehicle. And it's relying upon some centralized managed authority. And the IP address management history started with IANA, which is Internet Assigned Number Authority. In '97, there was 3 registrars. American Registry for Internet Numbers, Asia Pacific Network Information Center, and RIPE, European branch. Going on to the 90s, ICANN came about, Internet Corporation for Assigned Numbers, Names and Numbers. It is a private nonprofit organization. They remain responsible for all the IP addresses and domain management. So if you guys buy a domain name through GoDaddy or through any registrar, these folks are actually the ones overseeing. We're overseeing this in the 90s. Users and businesses obtain IP addresses from ISP like GoDaddy, things of that nature. It's probably the most popular that you guys are familiar with. There's other ones out there. Now going into the OSI model. This was developed by the ISO organization in the 80s, and it's a model for understanding computing. Last week we did a whiteboard. This is kind of the whiteboard for networking, this group. They just kind of did a whiteboard and they developed the ISO standards. It is a standard. It's nothing technical. There's no wires, components. It's just a standard. It is a model. It divides a network into 7 layers, the OSI does. Physical, data link, network, transport, session, presentation, and application. And in the next few slides, you'll see a breakdown graphically how that works and how some of them kind of overlay and overlap as well. The protocol interaction, meaning the layer directly above and below it, they generally interact with or overlap, you'll see. The application layer protocol, interacts with software. That makes sense, naming an application. And then physical layer deals with cables and connectors. Okay? So protocol, application, physical are the three breakdowns. It's theoretical in representation between two nodes. One computer here, and how they communicate is how this model is set up, how they send data back and forth between each other. Hardware and software independent. Every network communication process is represented because it is a theory. You can do that. That's why it doesn't fit exactly for everything, but it's a theory. Theoretically, it fits. And PDUs, they call what's called protocol data units. It's kind of a generic term in OSI to describe data, and basically flows through the layers 6, 5, 4, 3, 2, and 1 in the OSI model. It's generalized and sometimes imperfect, as I already mentioned, because it is a theory. Like most theories are not perfect. This one isn't either. So here's two computers, right? The breakdown of the OSI. We'll start here on the left side and go to the right side. The left physical path computer to the right physical path of the computer. So you start on the left there. On the left side, very left side, you got application, presentation, session, transport, network, data link, physical. Then there's a network medium. We'll say it's a Cat5 wire or fiber or whatever, Wi-Fi. Then back to the physical. The physical on both bottoms represent your NIC card. Okay, could represent your NIC card. On your computers, they do represent your NIC card. But depending on the device, it could be something else. The data link layer is from within your NIC card. There is components, electronic components that rides upon the system board called the bus that is in this data link layer area. Okay. Then goes into the network and transport and transmission. That's basically taking the data, which is at this point binary, and getting ready to push it to presentation into whatever application you're reading that data from, via maybe a web browser, you're viewing a web page, via music player, you name it. Okay, a picture viewer that you're viewing something from the web. That somebody sent you via email, possibly an email application, whatever application you could think of. And then what it does is, once it gets to that, from point A to point B, from left to right, it goes back again, continually going down again, application, presentation, session, transport, network, data link, physical, back through the loop, reverse to the other side. Your network is constantly doing this all the time. All the time. If you were to look around behind you right now, except for the back row, you can see the lights of your NIC card behind you blinking. Go ahead and do that real quick. And you'll have usually a green light and a yellow light. The green light is activity on your network. You say, I'm not really doing anything except playing Angry Birds. I'm not really doing anything. Why is it blinking? It's because it's constantly, all the time, doing what we're showing up here on the overhead. All the time the network is flowing. Now sometimes data is definitely flowing more than others, but data is always flowing back and forth on the network. The top level is the application layer I mentioned already. No software applications really, it's just preparing it for that software application like I mentioned, which could be any application you could think of. Protocol functions, it facilitates communication between software applications and the network service. And again, that network service could be an audio network, video network, data network, whatever type of data is coming across. The network interprets the application request. The application itself interprets the data and converts it for you and I to see, hear, whatever it is. Okay? Maybe a Word document, maybe an email, maybe a picture, a video, an audio. Software application negotiates with the application layer protocol, like formatting, procedural things, security, synchronization, other type of requirements that application might have. So for instance, say the application only opens up JPEGs and it's trying to push it to an application that's JPEG, well, it's not going to accept it. Okay, this is where the layer, application layer, all of that's in there, determining whether or not it's formatted correctly. Then the presentation layer is the protocol functions, accepts the application layer data, it formats the data into understandable format for different hosts that it might be on. Like for instance, if it's on a Windows server host like we are here on campus, it might be on Mac, it might be on Linux server host. Depending on the host it is, it formats to that data, into that host environment. Example would be also formatting of text, text encoding, bringing it across the different layers of text, media encoding, audio encoding. And so depending upon the network traffic, the format's going to vary. And so again, the bottom example is the presentation layer services manage data, encryption and decryption. Protocol function in the session layer coordinates and maintains communication between the two nodes. The session layer is a connection for ongoing data exchange between these two parties. Example, connection between a remote client and an access server, connection between a web browser and a web server. So when you log on to Eagle, which is hosted actually on the East Coast, you're viewing a server on the East Coast when you're viewing Eagle. It's actually hosted there physically on the East Coast. And so the session layer keeps that active. Now, in that session layer, you might guess, is such protocols of timeout, security, just to name a couple when it comes to web sessions. So like if you're on Eagle for 8 to 10 minutes, it times out, and then you have to log back in with no activity. And that will be on this layer. Continue on the session layer functions. In this layer, establish and keeps alive the communication link for session duration. That session duration has to do with the rules set up generally on, if we're talking about a website, be the web server sets up that session rule. So a 10-minute timeout with no activity. They must log in with successful username and password. Some might even have a session time frame. So from 6 in the morning to midnight, and that's it. That's the only amount of traffic you can have. You can't have anything from midnight to 6. Synchronizes dialogue between two nodes. It determines if communications have ended and determines where to restart it. And I always like to use this example here. Have you ever started downloading a file and it starts really fast and then it's like dirt slow in like 2 seconds? Or maybe even stop altogether. And you come back an hour later like, why did that thing start back up? It stopped like an hour ago. Because this layer here is smart enough when the connection comes back, maybe from that web host that you're downloading something from, it'll pick it back up where it left off at and start it up again and restart that transmission. It also has a terminating component in this as well. So if you log off of a website, it's in this session layer that happens. And then transport layer. In the transport layer, the protocol functions are, it accepts data, as you might guess, from the session layer we just left, manages end-to-end data delivery, handles flow control. It's connection-oriented in its protocols on this one. It establishes connection before transmitting the data. An example I give on this is, anybody remember dial-up days? Where you dialed up and it made the shrill sound, and then finally stopped and then connected and stopped the shrill sound. After that shrill sound is actually would be this connection transmission area of the OSI, the transport layer, before it authenticated while it's shrilling that shrill sound, and before it stops, it's authenticating it before it begins to send data. So no data, you couldn't go on the web or couldn't connect to anything until that connection was verified. And this is the area where it's verified in the transport layer. It also has in here a checksum. Checksum basically, to make you understand it, is every file will have a checksum, which is made up of a number of things. One would be size of file. It could also be the header information in that file, and also the source and destination IP address could also be in that checksum. And so when it sends that data, that 1.exe file, this information here that was sent has to equal that's received. Otherwise, it'll try to re-download it again. You might have actually seen that happen when you downloaded a file. It got to 99%, close to 100%, and then it goes, oh, failed, start back again. Very beginning, start downloading again. Could be a connection issue, whatever. You lost connection of a internet connection possibly. Could be on their end as well too. The website could have went down or locked up during the download. I've seen that happen. But what it does is, the main reason for checksum is it ensures data integrity, that what you sent is received, pretty much. Okay? Connectionless protocols are in this one. It does not establish any connection in the transport with another node before opening or before doing anything. The IP, you'll learn about in the video. The IP by itself, the internet protocol, is connectionless. There is no rules around it. It's kind of like the wild, wild west. It does whatever it wants, when it wants, and how it wants. Nobody can tell it what to do. And that's this area, transport layer. It makes no effort to ensure data is delivered, free of errors, has no checksum in this connectionless protocol. It's more efficient than connection-oriented protocol because it doesn't have the rules around it sometimes that cause things to slow down in a rule-oriented connection. It's useful when data must be transported quickly, or transferred quickly. An example of this would be FTP. There is an anonymous FTP account that can be set up on a website. And I was a web developer for years, and I still do some I still teach web developing, and do some local work. But FTP is an example of connectionless because usually no rules hardly. You can basically give somebody an FTP address, and if they can connect to it and have an internet connection, they can basically upload anything they want to that folder on your website using an anonymous FTP address. It's useful, again, for transferring things quickly. Definitely not good for security things, for sure, right? But if you're needing, like, I don't know, log files, an example of that would be a log file of users' activities on a website. Maybe another example would be on a public website, they have an FTP folder for images, for public images for that company to post images on. Newspapers use it a lot to upload articles for the next day. Segmentation in the transport layer, it breaks data apart into large data into smaller pieces, and it increases the efficiency of the data. So if you have say 100 meg file, we'll say this is 100 megs, it's going to take that 100 meg file and break it up, we'll say, into chunks of data. Each one of these would be a segment that it breaks it up into. And so it's more bite size to download or upload in the data transfer. MTU stands for maximum transmission unit. It's the largest data unit that can be carried in any one of these. This would be an MTU, whatever the largest one is. Generally, it's going to be fairly static for most networks, like an Ethernet defaults 1,500 bytes per data unit. Reassembly. So it's broken up, right, like a caboose on a train. It's broken up in transport. We'll use this as the example here. Here's a send and receiving. So So this is the actual 100 meg file sent from here to here. It's broken up into different areas, maybe on a network all throughout, transported from different switches and routers throughout the network. But when it comes back in, it's put back together from the 0 to whatever number it is that it's broken up into. We'll say 0 just for simplicity's sake, 0 to 100. Okay? And so it's put in order from beginning to end in the order it was sent, regardless how it's broken up here in the transport. It brings it back together in the reassembly. Then sequencing, method of identifying the segments belonging to the same group of data. So here we have an example of a sender and receiver on the transport layer. The sender sends a long message, goes through the transport segmentation, breaks it up as you can see, letter by letter here, goes through the network, puts it back together, and puts it up in through the transport layer reassembly for the end user or recipient to see. Okay? Very simplistic view, but that's basically what happens. Here's a screenshot of an actual transport layer protocol. You'll notice on the top line it has a source port 80, which is the internet port, the web port, which all, business, education, any network's going to have port 80 open if they want any web connection anyway for their users. Destination port is where it's going to. That can vary depending on where it's being sent, what type of file it's being sent. The sequencing number is just for that data packet layer. Acknowledgement acknowledges that. The sequencing and acknowledgement. The acknowledgement is in reference to a handshake on dial-up I mentioned earlier. The handshaking dial-up tone, where it went skrilled and then your handshake and then stopped shrilling and you were connected. That's the acknowledgement. And then the length and source port breaks it down here line by line on source port down, what was vertically just brought across. And then going down to the header length, the flags have like different things like congestion flag, urgent flag, synchronous flag, and then the window size of the screen, the checksum, it tells if it's correct or incorrect, and the options, generally how many bytes per data packet, and then the maximum size data packet, in this case was 1460. So that's an average checksum look, or of a data packet as it flows across just one. The network layer, this is the protocol functions on this, is it translates the network address into physical counterpart. It decides how to route the data from sender to receiver. So it decides the quickest route here from sender to receiver. Decides how that route's going to be. So if you've got, for instance, an organization, or if I do a Google search right now, and you do a Google search right now, we can actually be hitting different switches throughout the nation between where we're at here in Rock Valley College and where the Google server is. We could hit different, all of us could hit different switches to get there. And we'll actually do, I believe in the ping lab, I show you there is a tracer route command that lets you see exactly what switches were hit for your data to get where it went and come back. And that's pretty cool because usually a lot of those switches will actually have, and routers will actually have names of cities on the end of the name, like the IP address will be whatever, Chicago, Florida, Indiana, Madison, Wisconsin, will actually be in the name of the actual router or switch, whatever it's hitting. Then addressing is a system for assigning unique identification numbers to a network device. So I mentioned earlier already on the NIC cards, and we talked about this last week, I believe, how NIC card has its own built-in MAC address. Your network also has a unique address. Everybody in here, you have not only a unique MAC address, every client also has its unique network address given to it by the network. You also have your own unique IP address, okay? So IP address, which is resident to you, your NIC card, which does not change, the MAC address does not change. Your network address can change, your IP address can change, but the MAC address does not change. So in the addressing part, this would be done by the network itself. Types of addresses are for nodes would be like network address, logical address to a location, to a switch, to a hub, to a router. So all different types of addresses. These are just a couple examples of nodes. Continue on in packet information in the network layer. The transport layer segments, appends it into logical information from start to finish, from 0 to whatever. Then it routes that from point A to point B. And the consideration on routing is priority of that, what the priority is of that. You can, as a network, set up a rule on routers to give certain individuals, whether it be network addresses, IP addresses, or domain areas, you can give them certain priorities. Network congestion is also a routing consideration. Quality of service, and the cost of alternative routes. But routers are smart enough to figure out how to get there the best way, and not only the best way, that might not be the fastest way sometimes, but it'll get there. And you'll find that out when we watch the video. Sometimes it's not as fast as you might think it should be, but it will get there.
So a reason for like giving something priority might be, say, your file server, you want to give it priority over the one data hog you have in the company that's always downloading.
Oh yeah, definitely. You can definitely do that. You can definitely limit bandwidth to segments of your network, or even you can narrow down to Joe over in cubicle Z over there. You can limit him to dial-up bandwidth if you want to. Seriously, you can. And so you can do whatever you want to network-wise to set up those rules to get priorities. It's a good question. Now, the common network layer protocol is the IP, Internet Protocol, which I've talked about already, kind of wild, wild west. No real rules around that. You'll find some rules here in just a second here, which is the fragmentation part of the network layer, which is a network layer IP subdivides what's called the transport layer segment into smaller packets. And so basically it takes and fragments the IP and subdivides it so it can get the data where it needs to go. And again, it might not be the fastest, but it will get there eventually. And it might have to even resend it, you'll find out here in just a second. It might fail and resend, it might get dropped and have to resend it. Here's a network layer screenshot of an IP packet. A couple things I want to highlight on this one is a source and destination address. The source and destination address will be different. Generally also versioning is what IP version it is. I think I already mentioned current IP version for most networks are still 4, but we do have 6 available to us now as well. And everything's going that route. Any new systems. Header length, 20 bytes, just 20 bytes per header length. And the next differential service field, these have to do with just default fields that don't change much, and most of them are made up of zeros, and it's just a default service field in the IP packet. The total length of the IP packet is going to be found there as well. Identification for the most part on IP is going to be zeros because there's no rules around it. The flags are only 2. Don't fragment or have more fragment. Either set it or don't set it. And then time to live. You'll actually learn this in the ping lab. Every IP has a time to live on the network, and that refers to how many hops it has before it dies. How many times an IP address can hop from switch to router, router to switch, switch to router, router to switch, all throughout your network hops when you're trying to get somewhere. Protocols, TCP, that is the rule or the wrapper around IP that gives it the rule of where it's coming from, where it's going, length, all that is around the TCP. And that's transport control protocol. Transport control protocol is a rule wrapper around the IP. Then the checksum checks to make sure that what was sent is received. Then the source and destination is the same, and that's the IP packet.
Is there a reason all the IP addresses were from twice?
Yes, the top one is a one-liner that gives you how it would look out actually on a network. Below version 4 down is just an example of how it breaks down, basically.
Oh, I meant more why it's like there and then there again.
Oh, and the parentheses?
Yeah.
Yes, that actually has to do with the subnet. Sometimes those might be a little bit different, depending on the subnet that those systems are in. But they're generally going to be the same. Functions of the data link layer divides data into distinct frames for transmission into the physical layer. And remember, the physical layer is going to be what on your computer? The NIC card, right. So we're getting ready to go there from the data link layer into the physical here in just a second. The frame is where the packets begin to move, the structuring the packets for the moving of the data. It has raw data, and it's in binary format, zeros and ones coming across the network, and then it's putting it into the sender and receiver's network address. The error checking and control information are all part of the frame as the data is being moved. Possible partial communication mishap. Not all information can be received. This happens. It's corrected by the error checking. It realizes it didn't all get received, so it's asked for it again. The router asks for it again, that IP packet, and it sends it again. The sender will send it again. And then error checking through frame check sequencing. It has what's called the CRC, cyclic redundancy check, to determine if the data got there as well. If it didn't, it can ask for that IP packet again. Possible glut of communication request is also in this area. The data link layer controls flow of information, and it allows the NIC to process data without error. And so because your NIC card is constantly, as you can see when you looked at yours tonight, it's constantly communicating all the time. Not only that, but the routers that are connected to your network are constantly communicating all the time to every device. At any moment, they know what your health is of your NIC card, how fast you can receive data, and then it either speeds up or slows down that transmission to where you can get things successfully, get data successfully. There's two data link layers, and continuing on here, one is called the LLC and the MAC. The LLC is a logical link layer. It's a sublayer. And the MAC, which is the media access control sublayer, these are basically layers within the data link layer. You've already heard of the MAC address, which is a block ID of 6-character sequence unique to each vendor. So it could be a popular vendor like Intel, 3Com as a vendor, Motorola, and then a device ID would be a 6-character number added at the factory's factory, the vendor's factory. The MAC address frequently is depicted in hexadecimal format. And if you were to do like an IP config, which we'll do right now in just a second on your computer, to see what I'm talking about, I'll write up on the board. We'll do an IP config space /all. And you'll see a MAC address show up. So let's go ahead and do that right now. I'll show you how to do it. Okay, so on the start button of your computer, you'll click on the start button and go to the run command. start button, run. If you have Windows 7, the run command is actually right here where my mouse is. It doesn't even say run anymore, it's just a box. Start run, and then type in CMD for command, short for command. Okay. Then hit enter. Yep. Then you're going to type in the IP config space /all. The wrong slash. The other slash. IP config. It's actually called backslash, but it's forward slash. It looks like a forward slash. This one right here. Forward slash. I put backslash on the board. Actually, this is called forward slash, just like that. What this is going to give you is, once you type that IP config space /all, it's going to give you some information about your network here. So let's go and look at mine. You can look at yours. The first thing it gives you is the host name, which is your PC name. Okay, whatever your PC's named. Then it's going to tell you your node type, which is hybrid for most of yours, meaning you can just talk on multiple networks with your NIC card and on your network. And then IP routing enabled, yes. WINS proxy enabled, no. Okay. IP routing enabled means this IP address is generally going to be, when you see that, it's going to be what's called a DHCP routing, which we have here, which basically routes the IPs to you and gives you an IP address. The next is WINS proxy enabled, no. That's been around for a while, and what that used to be used for a lot was for naming resolution. Name conflicts on a network, it would resolve it in this area. You really don't need that much anymore in today's networking, starting with probably Windows XP Service Pack 2, but it's still there.
So if it says IP routing enabled, no, that means that I've got a fixed IP address on my computer?
Not necessarily, no. No, it's by default, IP routing is always going to be yes by default, unless you force that NIC card and go in there and program it to be no. It's going to also always be yes on the NIC, always.
Okay, this one says no.
Yeah, mine says no.
Your guy says no?
Yeah.
It's been configured that way then. It's going to be configured to be no. Ethernet adapter local area network. The next one, this is actually your NIC card, and it should be an Intel something. Mine is anyway. What is that? What your guys is?
Yeah.
Intel R825, whatever. That's the description of the NIC. The first name is generally the manufacturer, and then it usually has some type of code beyond that. The one I wanted to really for you guys to see on this was the physical address, okay, which breaks this down into hexadecimal into separated by dashes in here. And this is actually representation of an ASCII, hexadecimal to ASCII representation, okay? When your computer sees your MAC address, it does not see it as this. It sees it as hexadecimal. This is hexadecimal converted to ASCII. ASCII is text, okay? That makes sense? So like when you hit a key on your keyboard tonight, every key you push on your keyboard, regardless what key it is, has an ASCII code equivalent, a number equivalent to that key press. Same thing here. The reason they made the physical address look as such here is just to easily gravitate it and to document it, but it is in essence a converted from hexadecimal, because your MAC address is a hexadecimal number, hexadecimal address. Then DCP, your guys should say enabled, correcto mundo. Now we are in here in the Cisco lab, and so there's some times where that is can be manipulated, and somebody already mentioned it could be hard-coded IP address in. Auto config should be yes. If you ever do come in here, by the way, and you can't get on the internet, more than likely your IP address has been hard-coded in for a Cisco lab, and you just go in and set it to auto config and take all the hard-coded IP addresses out, and your internet begins to work because it goes back to the DCP server it's connected to. The next is the IP address. That's you, and we should all have unique IP addresses. There is instances where I've seen duplicate IP addresses where, say, for instance, you image a computer. What I mean by that is you take the hard drive and you literally copy it and duplicate it into a lab environment or into a work environment. There is instances when you do that, when you first roll it out, you might have some IP conflicts possibly that need to be resolved. But generally, upon restart, your network takes care of that when you restart your computers. Next is subnet mask. This is a default subnet mask of Class C. Just a real quick tip and trick here for you. To determine what class you are in a network, you have a Class A, which is a local area network to you, this room only, no internet at all, local area network. Would only be one octet would be filled in here. The rest would be 0. The first one would be, say, like a 10, and that'd be a .0.0.0. Okay. Class B is if 2 octets have something in it, okay, which would be like a 10.1.0.0 would be a Class B. Still on a Class B though, Class B you can have actual internet connection with a Class B network, which we actually have partially here on campus, Class B. And then Class C is what you see here, which is 3 octets have content in it. And that is generally a local LAN plus connected to a WAN environment outside of this building and the internet. The 127.0.0.1 is a default gateway. That's a server that's hosted, that this room is hosted on. It's actually not in this room, it's in the Cisco lab. And then DHCP server is the same. The DNS server, now this is the actual, DNS is actually where we get our internet from in here, okay? The DNS comes from Rock Valley College network because we're actually off the grid in here, and so the only reason we can see from outside in here is because of that DNS IP address that's in there, okay? Without DNS, you're not going to get the internet. It's not going to happen, okay, without your DNS connection. So DNS servers are there as well. It usually has a lease obtained when this IP was obtained. Mine was Thursday at 3:48, and it expires tomorrow at 3:48. So you have a 24-hour expiration date here, which is common. Yours might be different possibly on yours. That's set up on the network rules, by the way. And then I have another adapter you guys don't have, which is my Wi-Fi adapter I have connected to my desktop here for internet connection, for tethering on my iPad. And you'll notice it also has a unique physical MAC address. DHCP is not enabled on mine because I have it set up as an ad hoc network, meaning it's connected computer to computer and that's it. And so I have an IP address, a subnet, and that's it. Because I'm sharing the internet from my computer here through an ad hoc connection, all right? So that's how you find IP config, find out information about your network and about your, we'll learn more of these commands, by the way, when we do the ping lab next week. Highlight one right here, this slide right here, yeah, right there, that's it. There we go. Okay, now you've seen some of these when it comes to Wi-Fi. I'm guessing 802.11, most of you familiar with, right? You've heard of that, right? Probably. Up through 802.11. You'll notice the rest of them, 802.15, 16, 17, 20, and 22. These are actual standards for network wireless protocols. 15 is for wireless personal area networks. This is coexistent of wireless personal area networks, or PANs, with other wireless devices and unlicensed frequency bands. 802.16 is broadband wireless in a metropolitan area. There are cities called, and it's called WiMAX, that actually have this. Whole cities, Canada, there's a couple in Canada, one over in Quebec, near Quebec, that has a WiMAX area of 35,000 people that have WiMAX totally free. They can just get on the internet anywhere.
Didn't Aspen have something like that?
I think, yeah, you're right. There's a lot of little spots. New York City has a couple areas in the suburbs that have this, and so they talked about getting WiMAX in Rockford. I think it'd be pretty cool to have. They thought about doing it downtown during, starting out maybe during a business time or whatever, but I don't know. But WiMAX is actually fairly new, and it's broadband and very fast, very efficient. 802.17 is resilient packet rings. This is basically on this one, the Sonnet packet, which is basically shared packet transmission on ring topology. We went over ring topology last week. A lot of data redundancy on this one. High level security areas could use this. Factories with high noise resistance. Banking facilities that use Wi-Fi. And then 802.20 mobile broadband wireless network. Mobile WiMAX. If you've been to Schaumburg Mall, they actually have, I can't remember, I think it's Clear. Anybody know? Clear Communication? I can't remember the name of it. Anyway, they actually have this mobile WiMAX in the Chicago Schaumburg area. And I guess I've not ever experienced it. I've overheard them talking to guys. The reason I've not went in really is because I'll just get mad probably because you can't get it here. But I've heard people talk about it there, and if you buy into it, pretty much all of Schaumburg, near Chicago, you can get this mobile WiMAX in quite a few areas. And you have to pay a monthly fee, but you just, whatever device you have that has Wi-Fi, you can connect to it. You pay for the service. So they use a conglomerate of towers. There is some satellite in some regions they're playing with, and so pretty cool technology. It's really come down. I think it was like $35 a month or something like that for mobile WiMAX. Actually, cheaper than Comcast, if I'm not mistaken. I think we're $40. Is that right? $40 something like that.
Depends on your bandwidth.
Then 802.22 wireless regional area networks. This one actually has to do with TV stations and with their broadcasting, specifically when they went to to operate on the UHF, VHF frequency bands, which really with the advent of digital, this is still alive, but it's not used much because when the FCC forced all the television stations, when was it, I don't know, 2 years ago, 3 years ago, something like that, it has to be all digital. This still exists though, but it's not used as much because of the digital, over-the-air digital. So it does still exist, so I don't know what it's going to be used for. It can be used for something because that channel's open to be used. And so IEEE says, now there are other standards out there right now. I believe I mentioned, so 2 semesters ago, I had a student that was experimenting in the military with some new Wi-Fi technology with security. Because we go over that in here. WPA, you guys have heard of probably. You might have your home network set up with that, WPA security, which is fairly secure. But one of the reasons why military will not use Wi-Fi in a combat zone is because it's still not yet secure as it needs to be to have mobile devices in the field for communication purposes via Wi-Fi or any other type of Wi-Fi communication. And so they're working on, top secret stuff, but he said that it's pretty awesome, some of the security they got that's coming out. This was 2 semesters ago. I think he said something like 2014, I think is what he said, is when they're looking at probably rolling it out, to the States, that's what he guesses. So, but he can't say more than that, but he told us that during his presentation, which is pretty cool. But you'll find most of the new technologies when it comes to Wi-Fi go through military type of testing and, you know, governmental testing, not really civilian much. And so, not to say you and I can't find out about that if we know people, but there's only so much they can tell. Like I said, there's only so much he could tell us actually during the presentation. And so, but I really am personally interested in the WiMAX. I think that would be really cool to have. Comcast wouldn't like it, but who cares? They own everything anyway, right? And so, but I think personally, I mean, it's a grassroots thing. Most individuals in technology want that I talk to. They want that. They want the freedom of access for everybody to have. And I think we'll eventually get there, personally. I think we will. I think that's why you're seeing, though, mentioning Comcast, buying into other types of businesses. You're like, why are they buying that for? You know, why are they buying sporting companies and businesses? Because, do I know?
Didn't they buy NBC?
Yeah, they're buying up everything. They probably bought, I don't know if they did or not. I know they bought up a couple sport franchises here recently in the last 3 months. And pretty much all the Olympics was covered by them. But no, they're going into other routes because I think they see that there's things that eventually they're going to have to let go of, probably. And this might be one area that I've heard of that WiMAX would be one where they would lose the internet on that, or lose a big chunk of it anyway. Cable, once AT&T does get the drops everywhere for fiber, like they've been rumoring for the last 2-3 years, that will really hurt Comcast if that ever happens. I know in Rockford, the AT&T reps have told me the last 3 or 4 years, any new subdivisions, they definitely have fiber, but it's getting in the old infrastructure basically and getting it all in there that's taking so much time. And so, but that's supposed to be real. The one thing with Comcast is there's no competitors out there, and so really to compete with them. Because some areas, you know, you got, I don't know if you guys have heard of T6 Wireless. I know the guys that own that, and that started actually about 10 years ago. I met the owner because we lived in a rural part of Rockford. The reason I mentioned T6 is their point-to-point Wi-Fi technology. So you can have a rural farm, right, and get basically Wi-Fi, broadband over Wi-Fi, basically, is what they term it as. And they've got drops everywhere now. They started in Rockford, I believe they're now in Belvedere, Beloit, Roscoe, and they're, you know, expanding. And I could see these guys maybe being a part of this WiMAX move, possibly, I don't know. And one reason to mention them as well was the internships that you guys have been applying for, which I've been pretty excited about the last couple of weeks. These guys are expanding, T6 is expanding their reach, and they might be hiring some interns in the area of Wi-Fi setup and technology. So you'll be hearing more about that in the next probably month or so from me on that. So, but Wi-Fi I think is probably one area that still we're in the infancy stage in networking and data transfer and data security. That field in and of itself, if you wanted to get into a field that's going to just like in the ground level right now, it's still ground level. Anything Wi-Fi is still pretty ground level. And mobile Wi-Fi, WiMAX, all pretty ground level still. And in my mind, it's nowhere but to go up. And so if you're wanting to go into a field that's going to grow, and you can pretty much have your pick of where you want to go, what type of Wi-Fi type of networks you want to work at, that would be definitely a good field. Okay, well, let's go and take 10 minutes. We'll come back and do the video and be done. So, if you have any questions, come and see me.
So it's a short video?
13 minutes.